Hello students, today we will discuss about converse of basic proportionality theorem. Converse of basic proportionality theorem. In short, it is also called converse of BPT. Its statement is if a line divides two sides of a triangle in the same ratio, then it is parallel to the third side of this triangle. Now we divide this statement after the word ratio to get two parts of it. First part of this statement will be treated as given part of this theorem, and second part of this statement will be treated as to prove part of this theorem. Let us see what is written in the given part of this theorem. Here it is written, if a line divides two sides of a triangle in the same ratio, it means we are given a triangle and a line which divides its two sides in the same ratio. Let us draw its figure. Firstly, we will draw this triangle. Suppose we are given a triangle ABC and a line L which divides side AB and AC in the same ratio. Let us suppose line L intersects side AB at point D, and this line intersect side AC at point E. So here ratio of AD and DB is equal to ratio of AE and EC. That is AD upon DB is equal to AE upon EC. So we write given part of this theorem. We are given a triangle, say triangle ABC, and a line L intersecting sides AB and AC in points D and E respectively. Such that AD upon DB is equal to AE upon AC. says that AD upon DB equal to AE upon AC. Suppose this is equation number 1. Now see the second part of this statement. In the second part it is written that it is parallel. It means this line. This line is parallel to the third side. Third side means BC of the triangle. So line L will be parallel to BC. So we write to prove part. Line L must be parallel to side BC. To prove this theorem, we should have some constructions. So we mark another point E dash on side AC. Here E and E dash are distinct points, and we draw a line passing through D and E dash. And call it line L dash. So we write construction for this theorem. We draw another line L dash through point D intersecting side AC at point E dash, where points E and E dash are distinct points. Now proof part of this theorem. To prove this theorem, we will use concept of contradiction. So, if possible, let us suppose line L is not parallel to side BC. We supposed here, if possible, that line L is not parallel to BC, and another line L dash passing through D and E dash is parallel to BC, and another line L dash passing through points D and E dash is parallel to BC. So we can use basic proportionality theorem in triangle ABC. Here line L dash is assumed to be parallel to side BC. So this line L dash will divide sides AB and AC in the same ratio. That is, we will have AD upon DB equal to AE dash upon E dash C. Therefore, AD upon DB is equal to AE dash upon E dash C. Suppose this is equation number 2, and reason for this is basic proportionality theorem. Now look at equations 1 and 2. Left hand side of both the equations is AD upon DB, that is, these are same. So right hand side of these equations must be same. Therefore, we should have AE upon EC equal to AE dash upon E dash C. So from equations 1 and 2 we have AE upon EC is equal to AE dash upon E dash C. Now adding 1 in both the sides, we will get AE upon EC plus 1 is equal to AE dash upon E dash C plus 1. Now write 1 in the denominator of the second terms of both the sides. Now take LCM in left hand side. LCM of EC and 1 is EC. This EC divides this EC 1 times, and 1 multiplied by AE is AE, plus this 1 divides this EC times, and EC multiplied by 1 is EC, equal to, in right hand side, LCM of E dash C and 1 is E dash C. This E dash C divides this E dash C 1 times, and 1 multiplied by AE dash is AE dash, plus 1 divides E dash C times, and E dash C multiplied by 1 is E dash C. Now we add numerators of both the sides using the figure. In left hand side, AE plus EC. Look into the figure. AE plus EC, it is AC. So in left hand side we will have AC over EC is equal to, in right hand side, AE dash plus E dash C. See in the figure, AE dash plus E dash C, it is AC. So right hand side will be AC over E dash C. This AC cancel this AC, gives that we will have 1 upon EC is equal to 1 upon E dash C. On cross multiplying, we will get E dash C is equal to EC. Now look into the figure. E dash C equal to AC. E dash C equal to EC. This is only possible when E dash coincides E, because C is the point which is common in both the line segments, and these line segments are parallel to each other. So this is only possible if point E dash coincide point E, which contradict the fact that points E and E dash are distinct points, which contradict the fact that points E dash and E are distinct points. This contradiction arises because of our wrong assumption that line L is not parallel to side BC gives that line L must be parallel to side BC. To avoid this contradiction, look into the figure. Therefore, finally we got the conclusion that line L must be parallel to BC if it divides sides AB and AC in the same ratio, that is, if AD upon DB is equal to AE upon AC, then L must be parallel to BC. Hence proved. Thanks.